Welcome everyone to another Meyer webinar. Without further ado, let's get started. Today is going to be another Constellation webinar as we're about to discover, but before doing so, please allow me to welcome you. This will be the third and final Constellation webinar. The previous two are already available on our Thinking Sound YouTube channel as we speak, so be sure to watch those if you haven't done so already. Today's the third and final episode. It's all about Constellation and multipurpose halls. And that means that without further ado, I would like to introduce today's host, starting with the lead. Today, that is Pierre Germain. Pierre, are you with us?
Yes, I'm Merlijn.
Excellent. Thank you for joining us. Good morning to you. And we also have the venerable John Pellowe. Hi, John. How are you?
I'm with you.
Thank you for joining us. And I'm pleased to hand it over to Pierre. Pierre, it's all yours.
I'll just introduce myself. I'm the Constellation Design Manager at Meyer Sound. My background is in acoustics. I went to the University of British Columbia in Vancouver, Canada, where I specialized in acoustics, part of my mechanical engineering graduate studies. Then I went on to work in acoustic consulting firms. And in 2007, I joined Meyer Sound to join the Constellation team. So I will start with a short recap of what is Constellation. If you didn't see the previous two webinars, I'm going to explain a little bit what the system is and how it works before getting into some examples of multipurpose halls. So Constellation is a system of loudspeakers, microphones, and digital signal processing. And along with our acoustic services, it enables venues to change their acoustics by increasing the reverberation time and adding early reflections to suit various functions and performances. Before going into how Constellation works, I'll be referring to the term reverberation quite a bit, which is RT for short, reverberation time. So to define what reverberation time is, picture yourself in a large space, say a cathedral, parking garage, or warehouse, and if you were to clap your hands, it's going to take a while for that sound to decay until you no longer hear it, and that's reverberation. And reverberation time is the amount of time it takes for that sound to decay by 60 decibels or until you don't hear it anymore. So you might see in some publications or articles the terms RT, RT60, T20, T30. They all refer to the same thing. So if you see something that says this room has an RT of 1 second, generally means that in the mid-frequency bands, that room has an RT of 1 second. And because obviously reverberation will span the entire spectrum of low frequencies all the way up to the high frequencies. And there are two ways of reverberation, changing reverberation in a space. So reverberation is a function of how large the room is and also how much absorption is in the room. So using the cathedral example again, it's a very large space, but it has very little absorption. All the surfaces are very hard and reflective because you have stone, marble, glass, and these do not absorb sound very well. At the other end of the spectrum, if you picture yourself in a cinema space, for example, it's a much smaller room, has a lot of absorption, might have an acoustic tile ceiling, some acoustic panels on the walls, carpeting, very thick padded seats. And all of those contribute to reducing the reverberation time because they all absorb sound. So here we see an example of different musical and spoken word performances and the associated reverberation times for a room of, say, about 1,500 cubic meters. And as you can see at the left side of the screen, you have cinema, classroom drama. Those are all rooms that are important for spoken word. At the far right, we have symphony, pipe organ, or chorus. So those are classical performances where a long reverberation time suits the performance better. So if you have a room where you want to be able to do many of these performances, you want to be able to change the reverberation. You want to be able to increase it from cinema or classroom all the way up to symphony or pipe organ. So I'm going to give you a few examples of rooms with different reverberation times. So here, of course, you see a cinema. As I was explaining earlier, you might see there was acoustic tile ceiling up in the ceiling, of course, that absorbs a wide range of frequencies. The walls are generally completely covered with an acoustic material, which is generally fiberglass with a fabric in front of it. Obviously, you see curtains in front of the screen here. You've got some seats, you have carpeting, and all these contribute to very low reverberation time. So in this particular case, we're looking at 0.4 seconds. Then we move on to a classroom. So Again, room typically about the same size, but now we see some more reflective surfaces, which result in a slightly longer reverberation time. And 0.6 is generally the reverberation time that you're targeting for a classroom for good intelligibility. Moving on to music rooms, here we see a jazz club, which tend to be a little bit more lively, more reverberant. So in this case, we're looking at about 1.2 seconds. And then over into the classical music world, now we're looking at a typical symphony hall. As you can see, it's a much larger volume and a lot less absorption. And the end result is a room that's roughly in the 1.8 to 2.2 seconds for classical symphony halls. And last but not least, we have large churches and cathedrals that start about around 2.5 seconds, can go all the way up to even 12 seconds. And that's due to, of course, the large volume and the lack of absorption, which, of course, they have a lot of stone, marble, glass, and whatnot, and that all contributes to having a long reverberation time. So as you can imagine, if you picture yourself back into that cathedral and you're trying to have a conversation with somebody, that sound is going to be very reverberant. You're going to have a lot of difficulty in understanding that person, whereas obviously in a cinema or classroom, that will not be the case. So this is why it's important to be able to change the room acoustics so that you have proper intelligibility if you're using the room for, say, a lecture or for a drama. But then you want to be able to increase it if you have a classical music performance. So how does Constellation work? Well, here we see an example of how reflections behave in a room physically without Constellation. So on the left-hand side, we have a performer on stage. On the right, we have an audience. So as the performer is singing, their voice is going to travel through the air and go straight to the ears of the listeners. But also, you're going to have these reflections, and you're going to be reflecting off the walls, obviously off the ceiling as well. And those are what we call early reflections. And these are very important because they arrive shortly after the direct sound. And if you're close enough to the reflective surface, you're not going to hear that as an echo. It's just going to help reinforce that sound, and it's going to strengthen the direct sound a little bit. And the end result for the audience is you now feel a little bit closer to the stage, and it creates this sense of intimacy. And the reflections are also extremely important for performers themselves to hear each other on stage in the case of an orchestra. So what we do with Constellation is we put microphones over the performers on stage, and the sound of the performer is going to get into the microphones, and now we're going to be adding those early reflections. So if you treated your room to make it nice and dry for speech or whatnot, you may have some absorptive panels on the walls that are not generating those reflections, but now Constellation will do that for you. So this processor will create those early reflections, and we can manipulate the arrival time of the reflections, how strong they are, their frequency content. So there's a lot of controls that we can do. And obviously the sound is going to come out of the loudspeakers and reach the audience. So we call this an inline path. Likewise, these reflections, after they've passed the audience, they will kind of keep bouncing off the walls, and that's what's going to create reverberation. So here's a quick animation of what reverberation really is. It's essentially those reflections keep propagating until they lose their energy, and that's what becomes a reverberation. So with Constellation, what we do to increase that reverberation is we now have microphones in the audience to pick up that reverberation. It's going to be sent to the processor, and that processor has an electronic reverberator, and it's going to mix the sound of the room itself with this electronic reverberator, and then send that sound back through the loudspeaker. That sound will now go back into the room, back into the microphone through the processor, and that process regenerates itself. So we call that the non-inline process. And this regeneration is important because that's how sound behaves in a room. It's going to keep bouncing around. And all we're doing with Constellation is we're helping that process. And by manipulating the reverberator, it's similar to increasing that volume if you refer back to that previous slide. So we're going to see an example of how a typical layout of a Constellation system. So here we have a typical performing arts center. We'll start by putting microphones over the stage. And again, those are to create those early reflections. But on top of that, they're also going to be used to create the reverberation on stage. We then add the microphones over the audience, and those are to capture the reverberation of the audience or the auditorium itself. And then we'll start putting loudspeakers. So we start with loudspeakers around the audience, lateral loudspeakers around the musicians on stage, overhead speakers above the audience, overhead speakers above the musicians on stage. And then last but not least, the subwoofers, because we want to be able to recreate the entire frequency spectrum of reverberation. So what you see on stage on the left-hand side here is what we call the electronic stage shell. So we send the early reflections to the musicians on stage, and we can do some cross-pollination so that musicians on the right side of the stage can hear the musicians on the left side and vice versa. And of course, those early reflections will be sent to all the loudspeakers in the audience. And the end result is we leave the end user with a very simple interface. It's a web-based. It can be used, in this case, an example here on an iPad, but any touch surface will work. It can be done on a phone. We can also work with Crestron to recreate all those presets on Crestron. It can be recalled from the laptop. And we keep it as simple as needed. Generally, what we see here in this example here, there were only about 4 or 5 presets because that's what the end user wants. But typically, we have anywhere from, say, 4, 5 to maybe up to 10 presets. And then what you see down here are different acoustic settings. So each preset is a combination of how long the reverberation is, how strong it is. And the reverberation strength is similar to removing the absorption in the room. So by making the system louder, it's like taking away some of the carpeting and curtains and that sort of thing. Then we have warmth and brightness here. So that was the low frequencies and high frequencies. So you can adjust the spectral content. And in this particular case, we also gave them the ability to change how strong the early reflections were. And I'll get into more examples of different presets as we get into the system examples. And when you go to a performance, and it's not necessarily a classical music performance, but any performance, whether it's rock concert, a classroom, there are 4 paths of communications that are happening, and all 4 of them are very important. The first one, in this case here, is the musicians on stage need to hear each other better. So that's why we have that electronic stage shell. So we can help the communication on stage so that the reflections are arriving early, so that all the musicians are playing together and in time. And likewise, the audience should feel engaged with the performance. So that's why we have those early reflections that are sent out to the audience. And as I was explaining earlier, that you get that sensation that you're more connected to the stage, you feel closer to the stage. And one path that is easy to forget is the audience also needs to hear each other. And a story is when Cirque du Soleil inquired about Constellation, they were playing in these very large auditoriums that were extremely dry. And at the end of each scene, there was applause, but the applause would not carry for very long. And that's because the audience was not hearing the other end of the room. So by adding Constellation and adding reverberation, we create what we call audience enhancement. So now the audience can hear that they're in a big room, there's a lot of people around them, and that's what really helps with that sense of community in the audience. So it's very important to have the audience have microphones over them so that we can create that audience enhancement. And of course, you want that reaction of the audience to go back to the performers. They want to feel the appreciation of the audience. And that's also the case of, say, like a TV studio. You want to have the applause or the laughter to go back to the stage. And in the case of classical music, the same thing. Think of a worship space, more congregational singing to be able to get back to the chancel, etc. So now we're going to get into some examples of different multi-purpose rooms around the world. So we now have a presence in 27 countries and counting. Next year, we'll be adding 2 more countries, which will be Taiwan and Japan. We have now over 140 systems around the world. And I'm going to give you a few examples here. So we'll start in New York. This is a room that's called National Sawdust. And as the name states, it was originally a sawdust factory. And it was transformed into a concert hall with the help of Arup Acoustics out of New York. So in 2015, they opened this as a concert venue. So as you can see, it's a very unusual look to it, but it's also very cool. They have some great lighting, and they do a lot of very interesting performances in here. Types of performance you might find in this room ranges from classical music, experimental music, electronic music, rock and roll, folk, and other genres. The venue has hosted performances from musicians such as Yo-Yo Ma, Philip Glass, Yola Tango, and several others. In this room, in addition to Constellation, we also have Space Map, which is the ability to pan sounds across the room. So we added Constellation with the Space Map functionality in addition to a Meyer Sound PA in this room in 2019. And it really helped kind of expand all sonic possibilities of the venue. So now composers can really transform the space, which starts out relatively dry, into more reverberant concert halls. And at the same time, they can do those the creative panning of sounds across the room to do some very creative compositions. So during the installation of this room, since it was a retrofit, what we typically do when we want to hide speakers behind a material is we have a fabric that's sent to our factory in Berkeley, California. We do some acoustic tests, make sure that the fabric is transparent enough for the sound of the speaker to pass through. In this case here, since it was already constructed, we did the opposite. We actually sent some technicians on site in New York to put a speaker behind the wall, microphone in front of it, and verify that it was transparent enough, and sure enough it was. So that's why when you see this photo here, you don't see any of the Constellation speakers. What you see over here is obviously the line array and the speakers for the PA. All the Constellation speakers are hidden behind the walls and behind the ceiling. You see some microphones that are hanging down, and obviously we needed to have those a little bit lower than the ceiling. So the seating is obviously on the floor down here. People can also be standing or be seated in a small balcony. So you can see the tech booth back here. So it's just a very good example of a room that started. It was not originally designed to be a concert hall, but with the help of careful acoustic design and adding Constellation, now it's transformed into a really, really cool music performance venue. So staying in New York, we'll go to the Jazz at Lincoln Center and the Pellowe Room. This is the Jazz at Lincoln Center is home to the famous jazz musician Wynton Marsalis. And Wynton was introduced to Constellation when he visited Meyer Sound in Berkeley, and we took him to our small theater called Pearson Theater, and he brought his trumpet with him, and he was able to play in the different environments that we created. Went from a very short reverberation time to a very long one. And he also visited Zerlebach Hall that John Pellowe talked about last week, and he was very excited about it, and he wanted to add some more reverberation in his space over here called the Pellowe Room. So as you can see, it has a traditional kind of Greek amphitheater style of seats. It holds 483 seats, and they can do some reconfigurations in the upper tiers over here where they can put some tables as opposed to seats. In 2013 is when we installed this system. And again, it was a retrofit. So we had to do the same thing as National Sawdust. We had to make some tests to make sure that the fabric was transparent enough for the speakers to be hidden behind the walls, because obviously you can see that all the speakers are completely hidden. You can see the microphones over the stage here, and obviously you're seeing microphones at two different levels. The lower ones are for the early reflections, because as the name states, you want the reflections to be arriving early. So it's important to have the microphones fairly low. And of course, we weren't able to do the typical electronic stage shell that I was showing in the previous example, largely because of this large glass wall, which is about 90 feet by 50 feet. And of course, it has an incredible view, as you might have seen from the previous slide. This one up here, you have overlooks Columbus Circle and of course, Central Park. So in order to not obscure the view, instead of putting the loudspeakers at this level, we actually put them down on the floor. And so along with these speakers here, they create that small electronic stage shell. And during any calibration we do for all performance venues, we always invite musicians when we're finished. And then we do kind of some fine tuning to their liking. So in this case here, I've had the pleasure of Jazz at Lincoln Center provided a small jazz quartet. And they played with the system. We were able to make some adjustments, so we can do, for example, reducing the level of these floor speakers. If they're too loud, we can actually adjust the brightness and warmth. If we want to have some adjustments to the frequency content. So we always customize the presets to suit the musician's tastes. And when it was all said and done, Wynn was very happy. He actually gave us a really great quote. And in fact, we were told that he likes to have the system on before he walks in the room because he really likes the sound of the new acoustics. So that was a great anecdote from Wynn Marsalis. So we'll move from New York to Idaho. This is the Argyros Performing Arts Center. A beautiful new venue in Ketchum, Idaho, which is near the world-famous Sun Valley Ski Resort. It's a venue that hosts world-class performances as well as local events. The theater has 462 seats, and they can be deployed for theater-style seating, as you can see here, but they can also be completely retracted for cabaret-style events. We work with Auerbach Theater Consultants on this project, and the room was designed to be flexible enough to accommodate everything from live music, dance, spoken word, film, comedy, lectures, and workshops. So it's the main theater in the region where they can do all these different performances. And there are three separate systems in this room, but they can all work together. So you can see the PA, the line arrays, and obviously center cluster, line array. So they're used obviously for PA performances, but they're also used as left, center, right for cinema, along with these lateral speakers here, which are the HMS series of our cinema surround speakers. So these cinema surrounds will be doing cinema in addition to Constellation. And with Constellation, we also have some additional speakers down here that are horizontal, and that's for the flat floor configuration. So this room, there are different organizations that are using this room, everything from Sun Valley Center of the Arts, Sun Valley Symphony, Sun Valley Opera, as well as Sun Valley Ballet School. And even touring film productions such as the Banff International Film Festival, as well as local film festivals, also plan to show at the Argyros here. So here we see a photo of the seats that are retracted. And what happens when you retract seats like that is it removes all that absorption that the seats are providing. So, and it's also exposing the concrete floor. So now you went from a room that is kind of a low reverberation time, now slightly longer reverberation time. So what we typically do is create different presets for the different room configurations, which is what we did here. So here's just a quick snapshot of the control interface we programmed for them. They have microphones that are on reelers, so they have a microphone down and microphone off for when they do maintenance, and they have to raise the microphones. Different room configurations. So there's a raked seating configuration, flat floor, center stage, and those they compensate for that change of acoustics when the seats are retracted versus deployed. They also have curtains upstage, and when their curtains are in versus out, again, because it's an absorptive material, we have to make some adjustments to the acoustics to the different presets. So in each of these room configurations, they have their own sets of different presets that they can choose from. Now we'll move over to Montreal. This is the Cabaret Casino in Montreal. It's a multifunctional hall that's located in the Montreal Casino. Hosts a variety of events, everything from concerts, stand-up comedy to corporate events. And what was really fun with this project is one of the events that they do in here is boxing. So they'll remove all the tables that you see here. We'll put in a boxing ring. And one of the presets that we created was actually a boxing preset to make the room sound like you're in a big arena for those matches. And this is another room where the speakers were designed to accommodate the space map functionality, and really good sound programmer, local in Montreal, did a really nice a space map design. So if you go see a show, there's this introduction where it's a whole multimedia extravaganza where they utilize the lights in the ceiling, obviously the spotlights, and on top of this space map where you get this really cool sound design that's happening. So it's really impressive. And what was uniquely challenging with this room is, as you can see, this is a shot from the very back of the under balcony, which is very shallow. It's about 10 feet high. So when you're sitting under the balcony, because the ceiling is so low, you feel very disconnected from the rest of the room. And you can see the speakers that are poking through here. We installed over 140 loudspeakers just underneath the balcony with its own VRAS processor, reverberation processor, to be able to expand the acoustics or expand the reverberation under the balcony to make it sound like you're now in front of the balcony. So once the show starts, you really forget that you have a very low ceiling in front of you. So, and of course, you see the speakers that are protruding a little bit. We typically do our recessed speaker for under balconies. In this case, we weren't able to do that because of the limitations of the structure. Now we'll move over to San Francisco. This is the Toby Atrium Theater. It's located in the Wilesey Center, which is in downtown San Francisco, and it's home to the San Francisco Opera, which is the first opera company to use the Constellation technology. And this room is what they call a white box instead of a black box. And the reason for that is they're able to do projection mapping on any of the walls. And again, this was another room where we were able to hide the loudspeakers behind the wall And we had to make sure that, again, similar to Argyros, that the loudspeakers could also provide enough lateral energy at the right level for both the seating, the rate configuration, and also flat floor configuration. So in this room, there's 24 microphones, 75 loudspeakers, and of course, many of which are hidden behind the walls. In addition to that, we also have space map in this room, so it enables composers, conductors, artists to not only change the acoustic environments, but also send sounds across the room for very creative compositions. So as part of the acoustic design, we worked with Arup in San Francisco. And this is just another example of a room that was not really designed to be a concert venue, but using, obviously treating it acoustically and then adding Constellation. Now it works very well as a nice little concert venue. So now we'll look at the Duke Ellington School for the Arts. This is a high school in Washington, D.C. that's named after the famous jazz musician. The school went through a renovation in 2017, in which they added 800-seat theater that they call the Egg for obvious reasons. The School of the Arts has programs including dance, instrumental music, vocal music, visual arts, theater, etc. So here we see a view from inside the room. You can see there's two different tones of gray. These are all acoustic panels with acoustic fabric. In this case here, they wanted to surface mount the speakers, but we were able to color match the speakers. So you can see that we matched speakers to the white panels over here, and up in the balcony, matched the speakers, colored them gray to match the gray material up in the balcony. And if you've ever watched the web series called Comedians in Cars Getting Coffee, Jerry Seinfeld and Dave Chappelle walk into this room because this is a high school where Dave Chappelle went, and they comment on the acoustics and the sound system. So that was great to see when I watched that show. It was a nice surprise. As we typically do for performing arts theater, there has an electronic stage shell system. In some cases, we'll have the upstage speakers, as you see here, coming down on a batten, depending on the depth of the stage. But in this case, it was shallow enough that we're able to install them directly on the walls. And on top of that, we also have, you can see that there is an extension of the stage over the pit here. So we always extend that electronic stage shell to be in front of the proscenium as well for those instances where you might have musicians in the pit, or you might have the orchestra that sets up, all the way to the front edge of the pit. So a similar venue, this is the Palo Alto High School, is in Palo Alto, California. We worked with Shallock Collaborative on this project. Again, a very multi-purpose room, 584 seats, and it's used for instrumental, choral, theater arts programs. Another example of a room where the loudspeakers are doing double duty. So here you can see the larger ones. These are the cinema speakers again. These ones are doing both Constellation as well as rear cinema surrounds. And of course, we're using the ones on the sidewalls as well. And then we supplemented the sidewall speakers with a couple more lateral speakers here that you see. And here's a view of the stage again. In this case here, you can see the example of a loudspeaker that's actually suspended from the batten. So what we do is we put the overhead speakers and lateral speakers on the same batten. That way they can be flown out very quickly and very easily, which saves a lot of time and changeover. So if you have a performance where you're not using the stage shell and you're putting set pieces or whatnot, we can actually fly out the entire stage, and there will be a button on the iPad or a control surface that says stage off. And that way you can have different configurations of the stage. And we had a really good testimonial from Michael at the school. He really loves the system, and for him, he said it's been a game changer. And he likes to demonstrate the system by having the choir sing from different parts of the room. So they can be singing from the very back of the room or one side. Can do some interesting things like putting the boys on one side, girls on the other side. So that's what Constellation can really open up possibilities like that. So now we'll move over into Asia. We'll cross the Pacific. This is the Singapore American School. This is the room where we installed Constellation in 2015. Like a typical high school, it's used for everything from musical theater, choral groups, band. And I wanted to show this slide because if you saw last week's webinar where we looked at the Singapore Conference Hall, the Singapore Chinese Orchestra came to this room since they already had Constellation because they wanted to experience it and wanted to have the experience of playing with it and hearing it. And this is the room that kind of helped them make that decision to go with Constellation. And as you can tell, the sidewalls are really interesting. These are fiberglass panels that are kind of like in a triangular shape to get a little bit more absorption. And the ceiling was also extremely absorptive. And then, of course, the seats are very thickly padded. There's carpeting everywhere. So in the end result is when they pull down the curtain on stage, this room goes down to 0.5 seconds, which for a room of 900 seats is quite outstanding. So the contrast between a system off to, say, the symphony setting, which is about 2 seconds, is very dramatic. And just another shot here, it has its own under balcony system here. And what was challenging with this room, since it was an older space, we weren't able to attach the speakers directly to the ceiling. So we had to make sure that the installer had everything connected all the way up to the structural roof. But just an example of how we can work around construction limitations or weight limitations like that. And staying in Asia, this is a room that we did in around 2011, I believe. Just want to show this room as an example of a room where, again, the lateral loudspeakers are all completely hidden. So they did some tests on site, and they actually sent us some fabric samples of the materials and found that it was transparent enough to put the lateral speakers. So this is a room that has its own under balcony system as well, has a full electronic stage system on stage. And here's a shot of how they were able to cantilever the overhead speakers from the catwalks. We always make sure that the speakers are accessible for servicing and also for installation. And this is a great story, is that when the Les Miserables team visited the hall, they were thinking of bringing their own sound system, but then they listened to Constellation, they listened to the PA, and they were just like, well, no, we don't really need anything. So this is a good example that, it actually kind of helps touring companies. It might not need to bring the additional equipment if you have a full complement of Constellation as well as a good PA system. And so going down, now we're in Australia, and this is the Alexander Theatre that's located at Monash University, which is in the outskirts of Melbourne, Australia. It's a 561 seat theatre. It goes back to the 1960s, and the original uses were spoken word theatre, musical theatre, ballet, and dance. So the idea, they were actually thinking of demolishing the theatre and build a brand new one, but they decided to renovate it instead. And here we can see the transformation from 1967 all the way into 2018 when it was completed. So as part of the renovation, they really wanted to extend the uses of the theater and include to everything from folk, pop, jazz, classical music, soloists, ensembles, orchestras up to 60 musicians on stage. And they also want to expand the orchestra pit, which you might be able to see here. This is the extension over the orchestra pit. They wanted to expand that to accommodate up to 25 musicians. So again, we worked with the consultant and the architect. The architect was Peter Elliott. The consultant was Marshall Day Acoustics, to hide the speakers behind the wall. So the speakers themselves are inside these soffits, these boxes inside the wall, and with an acoustic fabric in front of them. And here you see a shot from the rear of the room. And of course, we have a full Constellation stage shell on stage. In addition to the orchestra pit, also has Constellation. So there are microphones inside the pit to pick up the pit musicians, and that's to send the sound from the pit musicians back to the stage and also out to the audience. And at the same time, we have the sound of the musicians on stage for an opera, for example. That sound can go back into the pit, so we can do that cross-pollination that way. And the impetus to renovate the theater, it started with Professor Paul Grabowski. So in addition to serving as the executive director of the Academy, University's Academy of Performing Arts, he's renowned throughout Australia and beyond as a jazz pianist and composer for opera, film, and television. And he came to Berkeley, and he was able to play in our Pearson Theater with Constellation, also Spaceman. And we also took him to Soundbox, which is one of the rooms that I talked about last week. And it was during that performance at Soundbox that he made the decision that this was the right solution for him. So now we'll move over into Europe and into Norway. And what's commonly found in Norway is small communities will have one theater, and it needs to be able to host a wide variety of performances. And the first one we're going to show here is called Kongsberg. This is a room that has about 600 seats. And again, we had to hide the speakers behind, in this case, was a metal grill. And it is a cinema system as well. So it's the same type of speakers, the large HMS10s. And another room where the seats are completely retractable. So you can see that all of these seats here will actually collapse and retract all the way to this level over here. There's also a Meyer sound PA system in here. And it's a pretty common. We have 2 or 3 theaters in Norway that are kind of very, very similar. Black box theater, very modular, very multi-purpose. And here's a shot of the stage. And this is a good photo to show how, when we work with the theater consultants, or in this case, it was our distributor, right, Norway, we always want to make sure that visually we can hide the speakers, which is usually an architectural request, but also to make sure that there's enough separation between in this case, the borders, so not to block the coverage pattern of the speakers. So when you look at this from the audience, you don't see these speakers at all. And so John can give us a little anecdote about what this slide is about.
Well, when the hall opened, the whole community came together, and these little places are so important in Norway because they're quite a long way from other towns and cities sometimes. And for this opening event, they had just about everyone on stage, and they had pop music, rock music. They had a little bit of everything. And if you go to the next slide, Pierre, you'll see that even the kids, all the local kids were roped into this opening event, and every kind of musician imaginable. But then in the same event, you'll see that we can have a classical event with just voice and piano with, at the next slide, just simple acoustic support with no microphones visible whatsoever. That was using the Constellation system, the same stage shell that you were looking at just a few moments ago. So these are really versatile halls. That's why they're so popular in Norway, because you can do literally anything in them.
So staying in Norway, we'll move over to Moss. So this is a room, very similar size, but obviously a different shape. It's not a black box like Kongsberg, but it has obviously a small balcony here. You can see our small loudspeakers. These are MM4 XPs, which are kind of like our go-to speaker for these types of venues. We have slightly larger speakers up in the ceiling, and we always make sure that we have lateral speakers on both levels. So depending on how many balconies that we have, and in addition to some balcony front speakers, so that these can kind of serve the front of the audience over here. So just like Kongsberg Community Theater, this one has about 400 seats used for everything, including drama, classical music, and rock concerts.
Absolutely, and just to chip in here, it was a really, really bad acoustic to start with. I went into this room when the restoration was starting, and it was really not liked by anybody. So fortunately, Breckenstrand came in and helped work with the architects to design the renovation, and the end result was really good.
So here we see a view of the stage shell during the installation of the acoustic treatment. And one thing that's really important in all our venues is to make sure that the reverberation time on stage is as dry or even a little bit drier than the audience, the auditorium side. And that's so that it makes the calibration a little bit simpler, because now, regardless of whether the curtains are in or not, you still have the same acoustic on stage. And it just allows you to have a lot more control. What's commonly found on stage is a flutter echo that you might get from the two sidewalls over here. So that's an echo that goes back and forth. And in some cases, the back wall, the upstage wall, can create also a reflection that goes all the way back into the audience as well. So with all this acoustic treatment, we're able to really neutralize those reflections. And that way, Constellation can take care of, reintroduce those early reflections. Now we have a lot more control, and as well as adding the reverberation on top of that. So in this case here, there's a total of 175 square meters, because it's a very tall fly tower, which is pretty common. And you can see also in this photo, you can see the upstage speakers here. You can see the microphones that are hanging down. Obviously, everything was raised to be out of the way to make room for the telescopic lift, of course. Just another shot again, the acoustic treatment in progress with the upstage speakers. You can see down here, there's still a few panels to be added, but the end result was a really nice dry acoustic. And John, I imagine that it made the tuning process much simpler as well, right?
Absolutely. The last thing you want is a stage with a sound. You want the sound to be as neutral as possible so that, as you say, whatever you put on the stage, it doesn't make much difference, because whatever you've got on the stage, it will couple with the auditorium. And if the stage has a big sound signature and it's reverberant, it's going to mess up the sound in the auditorium as well as on the stage. So they did a really good job of this. And yeah, it works really well.
Yeah, and another important thing that we sometimes find in flight towers and on stages is the HVAC noise. And that's one topic that we haven't touched on yet, is just to make sure that the HVAC sound level in the room is fairly low. We generally prefer anywhere about NC 25 to 30 is what we target. And we've had some instances where there might be like a large return air vent on stage that makes a really loud noise, and that obviously will get picked up by the microphone. So the HVAC sound control is really important in addition to the reverberation time, especially on stage, since that's where the microphones are, and it's going to be broadcasting that sound throughout the entire auditorium. So here's the interface for MOS. So you can see it's a little bit more expanded now. We incorporated what we call user presets, and that means that the end user can start from any of these presets that we program, but also make some adjustments to them and then save it as their own preset, and then they can go and name it whatever they want. So they can call it for jazz on October 23rd, because maybe musicians want something a little bit louder, a little bit softer. You can go and save it and capture it as your own user presets that are then rewritable as needed.
And just to add there, Pierre, if you go back to that slide, if you look at the PA performance type, that is designed specifically to work in conjunction with the PA. So you've got Constellation and the PA running together, which actually work really well together. It gives the PA a better sound. It slightly increases the source width of the line arrays, and people, if they're listening to a live performance on stage that's amplified, by switching the Constellation system on in PA mode, somehow the PA just disappears and it all becomes one fantastic musical event.
Absolutely, yeah. What I find with our PA settings is if the room is really dry, you'll be able to localize to the left and right, line arrays really quickly. But by adding just a very short, solid reverberation time and rolling off the low end, so to keep the bass tight, it really helps that envelopment. And again, it makes it feel closer, and it kind of helps blend the PA together. So it's a very effective preset. So in this case here, this is very typical in terms of the reverberation length. We'll go from shortest to very long. And all those presets that you saw on the previous slide, and we'll recall whichever length that is necessary for that particular preset. And what we have here is a stage on and stage off, as I was explaining earlier. If you need to fly out the entire electronic stage system, you can just have a button that turns microphones and speakers on stage on or off. In some cases, we've even done like a half stage configuration. So for example, in opera, if you might have set pieces along the upstage wall, you can just turn off the upstage portion of the stage shell while remaining keeping the rest of the system on. And then also we have, do you want to talk about rehearsal mode versus performance?
Yes, yes, absolutely. I do this in virtually every system now. When we go into performance mode, we add a little bit more reverberation time, and we add a little bit more acoustic strength into the room to compensate for the absorption of the audience. And it makes a big difference, actually, because the room does change, especially, funnily enough, small rooms can change quite dramatically when they're occupied. And so we found this to be a really useful facility.
And here's just another page of the web interface where they can actually make some adjustments to the strength. So I was explaining earlier, strength is like removing the absorption. So by making the system louder, it's like taking some absorption away, or by making the system quieter, it's like adding more absorption. So it's a different way of changing the reverberation time, in addition to the warmth and brightness, which are the two EQ controls explained earlier. So now we'll still staying in Norway. We're now at Baronet Rosendal, a room called Readersaal. And this is a room, as you can tell from the strange shape, it started out as a barn, but it was transformed into a concert venue. for the Rosendahl Music Festival. And John, you want to explain the addition of the acoustic treatment, I should say?
Yes. It really was a cold and windy place when it was before the restoration started. And it took some vision to see it like this finished. But there we are. But Breckenstrand, again, worked with the idea that it would be impossible with this volume to actually create a physical room. And so we had to use Constellation, and they deliberately made the panels in the ceiling as absorbent as possible. Yes, absolutely. The idea being that you kill the first reflection so that the people sitting in the audience aren't aware of the size of the room. And then we simulate a bigger space using Constellation, appropriately delayed, with the loudspeakers delayed. So it worked really well. Had those surfaces been reflective, it wouldn't have worked so well, because you'd have always been aware of the room being quite small, and it's a long, narrow room. So it would be quite tunnel-like as well, which in itself gives acoustic problems. So that was a really good achievement on their part. There's another view of it there. And you can also see the loudspeakers underneath. You can see the MM4s and also overhead UP4 loudspeakers. There we go. Yes, they're throughout the building. There was no attempt to hide the Constellation system. And you can also, if you look very carefully, you can see microphones as well. So that's been really successful for us. The Rosendahl Festival, unfortunately, didn't take place this year for obvious reasons. But the previous years, it's been really successful. And I always like to go there to join the artists and work with them and learn about acoustics from them, as well as them learning from us.
Yeah, plus, as you can see, all the loudspeakers and microphones are all white to match the decor of the room. So our microphones do come in black and white. So in this case here, white was the right choice, of course. And there is a small balcony up here, John, that had to have a little bit of careful adjustments, right, to make it work with the rest of the room. We
did indeed. Yes, that was a challenge. We've actually got, I think this was before Ashby, so it's Stellar fours above the balcony, and it worked. It worked really well in the end.
Yeah, go ahead.
I was just going to say, Life Over Ansness has been a terrific supporter. I mean, he got the idea to put Constellation into this room from his performance in Fosnavåg, which was another room similar to Kongsberg in Norway that we just showed you. And so he had this idea, we put it in there, and now he's really pleased with it. Christian Tetzlaff, also another artist who's performed at the festival more than once.
All right, so now we'll go to Lithuania. This is a drama theater that dates all the way back into the 1800s. It's a very historic building. They did a renovation. I guess this was about 2015. And it was a room that is used as obviously primarily for drama, but they wanted to expand it to everything from chamber music to all the way up to choral music. So there was different presets to really increase reverberation time. And it's a bit of a different layout that we've seen. Of course, since it's a drama theater, it has two very short balconies, and the idea is obviously for the sidelines and didn't have the audience close to the performers. But it was the almost a perfect room to add Constellation, just because the sidelines were already there. The basic acoustics were great, and we're just able to expand and really increase reverberation time for all these different performances. And what's, again, like many other halls we talked about today, it does have retractable seating. In this case, it's a gala seating system. And if you're not familiar with gala seating, I suggest that you Google it, because it's really interesting how it works. What you see here is actually the back side of the chairs, and every row is on a giant piston, and it pushes the chair up, and the chair is upside down, it flips around, and then it comes back down. And that's how they do that row by row. So it's really fascinating to see how that operating. But it was the same type of situation here, where obviously with a hard floor versus seats, there was two different acoustics that are happening. So we had to make sure to accommodate the two different room configurations.
And the acoustics were designed by Henrik Muller from Accucon. And the nice thing about this room is that with the Constellation system switched off, the clarity, the STI, is still very good. Mm-hmm. So it doesn't matter where you go in the room, you can hear clearly, but just the room is very dry. And so it's fantastic for drama with a little bit of Constellation as well. That works really well in that room.
Yeah, absolutely. And it's a good example of how, we always want to work with a room that sounds great acoustically to begin with, because then Constellation is just going to make it that much better, as opposed to doing the opposite. If the room is bad acoustically to begin with, Constellation is only going to amplify some of those defects, if you will. So it's important to have a good acoustic treatment or a well-designed room acoustically, and Constellation will now take it from there and expand reverberation time.
I absolutely agree with that. And it's so important that we work with good consultants and acousticians and architects and everyone who comes together to make these systems work well.
Yes, absolutely. So we'll finish up in Germany as a room that's called King. That's located in Ingelheim, which is near Frankfurt on the Rhine River. And the same type of venue as we've seen before, because it's a small community. It's one theater that had to do everything. So here you see a layout of this is a stage that they bring up for this type of performance here. I think this was one of your demos, I believe, John. And what was really interesting with this room, the acoustic treatment was really well done. I'll see some acoustic panels up on the ceiling, and I'll show you a slide coming up. All you see here, you see is wood, but it's actually an absorptive perforated wood. And our speakers are also hidden behind some fabric over here that we had to test. And what was one of the challenges when we started calibrating was these circles here are actually air vents, so from the HVAC system. And because of the location or the level that we had our microphones, the ones on the edges were actually picking up the air. So we had to make some adjustments, and the best adjustment was actually raising the microphones a little bit just to get out of the air path and eliminate that rumble was happening in the microphones. And then we were able to calibrate the system just like the rest of any other system. Again, the seats are modular. And this entire seating section will actually flatten down. So they can do dinner functions and conferences and whatnot. And it's not shown in this photo, but at the other end of the room, there are actually the walls can open up to expand for any type of kind of spillover audience. So we had to make sure to expand and extend Constellation all the way into the back of the rooms, which are actually used as classrooms when they're closed off. So similar to any other room, whenever there's a stage location, we have an electronic stage shell system, which is what you see here. And here you can see the speakers that are covering these side balconies here. So here's a close-up view of the acoustic treatment. It's a perforated wood that does a really good job of absorbing sound. So when you walk into this room and you see that it's all wood, you have this impression that it's going to be very reverberant, but it's actually quite dry. So it starts at about 0.8 seconds, and with Constellation, we bring it all the way up to 3 seconds for choral performances. And
just one thing to chip in, Pierre. Grana and partner, the acousticians, Dominic Schenker and Mrs. Grana herself, we started talking about this room 4 years before it happened. So we were in discussion with them right from the get-go. So the room was designed around Constellation, and those rooms are always the best ones,
Absolutely, yeah. And yeah, we did get some really great testimonials from Malte Schaefer from the Philharmonic State Orchestra of Mainz. And it's always great because we want to make sure that the musicians are happy as part of Constellation. And so we spend a lot of time during our calibrations to make sure that musicians are hearing each other on stage, that they feel nicely enveloped, they feel that they're supported, that they're getting the response from the audience and from the room itself. So that concludes our presentation for today. So now we can, I'll hand it back to Merlijn.
Thank you, Pierre. Awesome presentation. Thank you, John, as well. So I would like to thank today's co-host, John Pellowe, for chipping in, as he says so very eloquently. Thank you, John. Great pleasure having you here for these 3 Constellation webinars. Much appreciated.
Thank you.
And of course, also today's lead, Pierre Germain, Meyer Sound's Constellation Design Manager. Thank you for joining us for another great episode. Much appreciated.
You're welcome. My pleasure.
On behalf of Meyer Sound, thank you for watching today. And please stay safe. Please remain healthy, and best to you. and your loved ones. Bye-bye.